Hi, and welcome to this flipped instructional session. This is Middle School Earth Science, Semester A, and today's topic is Lesson 4.04, Continental Drift, and I am Mrs. Fessel. So we're going to start out by talking about what is continental drift. Continental drift is the theory that the continents were previously joined together, and over time they broke up and slowly drifted apart to their present location. So you might think, why don't I see the continents moving? This is because it's really slow. For example, if you were to use a teaspoon to load up a dump truck with sand, it would take you a long time. In the same way, if a continent on Earth moves just a centimeter or two a year, it would take a long time to move as far apart as the ocean is wide. It can take 100 million years. So this is a very slow process of continental drift. The first scientist who came up with this theory was Abraham Ortelius. In the late 1500s, Dutch mapmaker Abraham Ortelius said that the arrangement of the continents in the past was very different. He was the first one to propose that the continents were once grouped together into a supercontinent that broke up over time. He saw that the edges of the continents appeared to fit together like a puzzle. You can see that between South America and Africa right here. However, he didn't have any scientific evidence besides that, so it was just a theory. Alfred Wegener is the person who made it popular. In 1915, so almost 400 years later, Alfred Wegener formalized the idea when he presented the theory of continental drift. Very similar to Abraham, he believed that the world's landmasses were once joined together as one giant supercontinent, called Pangaea, which means one or all land. He said over about 200 million years, Pangaea had broken up and the land slowly drifted apart into two supercontinents that he called Gondwana land, which would be down here we have Africa, South America, Australia, Antarctica, India, and then Laurasia, North America, Europe, and Northern Asia. So here's a little more detailed picture of the continental drift of the plates. Here we have Pangaea about 225 million years ago. Then about 150 million years ago, we have Laurasia and Gondwana. About 100 million years ago, you see the continents start to drift towards their current locations, and here is the Earth today. So Alfred Wegener developed his theory, and he found evidence. The first one, to show that these rock formations had formed and broken up several times. So scientists actually now believe that 1.8 billion years ago, the continents were together in a supercontinent called Columbia. Then they believe it reassembled into a supercontinent called Rodinia about 1 billion years ago. Then about 750 million years ago, Rodinia broke up. Pangaea formed about 300 million years ago. And then actually in another few hundred million years, they believe Pangaea will reform again into another supercontinent. So what made people believe Alfred Wegener was he had evidence. His first piece of scientific evidence was fossils. For example, in this map here to the right, you can see that the bands of these ancient reptiles go across are only found in South America and Africa. Or this fern, Glossopteris, is found all along this green path here, which would only make sense if the continents were attached like this. The Lystrosaurus is found through this band right here. So other things that scientists use is that they see that modern day animals, for example, the kangaroo in Australia and the possum in North America, are related through a distant ancestor. So they believe that that ancestor was able to travel between Australia and America. So Wegener highlighted the fossil evidence to show that the continents were once united. Other evidence that helps prove Pangaea was similarities in rock layers and mountain ranges. For example, when the continents are placed together, old ancient mountain ranges line up. For example, the Appalachian Mountains in the eastern part of North America match up with mountain ranges in Great Britain, Norway, and Sweden, which makes sense if you put the continents back together. The bodies of water that separate this chain of mountains have come into existence since Pangaea broke up. Another way that Wegener supported his theory was through ancient climates. For example, South America, Southern Africa, India, and Australia all have very warm climates today because they're up here by the equator. And they're all far apart from each other. But landforms on all of these continents indicate that they were once glaciers there and that they were together under a huge sheet of ice in the colder areas of Pangaea. So down here in the south, you can see that Antarctica, which is still covered with ice, was attached to South America, Africa, India, and Australia, and they were covered with ice too. Other places reveal evidence of dramatic climate change. For example, tropical swamps once existed in areas that are now much colder, such as parts of North America, Europe, and Northern Asia. If you look right here, North America, Europe, and Northern Asia were also much closer to the equator than they are today, allowing them there to once have been tropical swamps there. So even though Wegener had things to support his theory, reaction to his theory was hostile and often exceptionally harsh and scathing. Because even though he had all of this evidence, he didn't have any mechanism for how these continents might move. So he thought that the continents were moving through the Earth's crust like icebreakers, plowing through ice sheets, and that there was some centrifugal and tidal forces moving the continents. After Wegener's death, his theory had some supporters, but the majority of the geologists continued to believe in other theories such as static continents and land bridges. In the 1950s, increased exploration of the Earth's crust, specifically the ocean floor, began. And then, finally, in the 1960s, plate tectonics, the theory of plate tectonics and continental drift, was well supported and accepted by almost all geologists. So his theory that the continents plowed through the ocean floor was not correct, but his theory of Pangaea was. As you're going to learn in upcoming lessons, both continents and the ocean floor form solid plates, which float on the asthenosphere, which is an underlying rock that is under such tremendous heat and pressure that it behaves as a very viscous or thick liquid, and that is what moves the continents along. So beware, as the continents continue to drift along, creeping a centimeter or two a year, eventually, as I mentioned before, scientists believe the Earth might look something like this, that the Atlantic Ocean will widen for a bit, but then the continents will come back together and form Pangaea again. That is the end of today's flipped recording. Look for the flipped follow-up in your Class Connect schedule, and I hope to see you there. Thank you and have a great day.